Well, it's just gone past 7 o'clock, and I shouldn't quote Monty Python here because no penguins are going to be exploding on top of television sets. So welcome everyone to the latest CILT webinar for 2021. It's October, as we know, and once again, we're going nationwide with this broadcast. And I'm quite excited tonight because we have a very, very interesting topic and a very, very interesting speaker. So before we get started, before I ask Diane Edwards to take the floor, I'd just like to give you a bit of interesting background here. Now, I want to talk first off about the topic tonight. We all know that companies which explore innovation outside their own domain are often those best placed to innovate. Uber and Ola, for example, revolutionized short-trip passenger services that were once the domain of taxi companies. Few within the industry saw them coming. These outsiders assist in prompting organizations to adapt and spark new ideas about services, products, or even business models. Disruptors are innovators that you don't see coming, so the best defense is to be the innovator. Tonight, it's a great pleasure, CILT New Zealand, to have chartered member Diane Edwards talk to us to give us insights into a range of future innovations and scenarios from outside the transport sector that may challenge our views on what transport will be needed in the future, what it might look like, and the infrastructure needed to support it. Diane is an experienced executive and business transformation facilitator, enabling organizations to prepare for the future of work through practical initiatives to transform the business to be agile, resilient, and innovative. She draws on a strong academic background with postgraduate qualifications in education, accounting, and banking, and she enjoys turning concepts into real-world solutions. She lectures periodically, by the way, at the business schools at Victoria University of Wellington and at Auckland University. She's published articles in accounting, banking, training, HR, shipping journals, and spoken at numerous conferences over the years across 4 continents. So, when not working, I wonder how Diane finds the time for this, to be honest. Diane's a science fiction geek, like myself, yay! A glider pilot, which I didn't know, and a world traveler. So welcome, Diane. It's a real pleasure to have you tonight, and the floor is yours.
Well, hello, everyone. It's wonderful to be here, and it's wonderful to see so many people who are here on the webinar. I'm just going to share my screen. Right, so I'm just going to tell you a little bit about me just to launch off. You've heard a few things about me, but there you'll see the New Zealand flag, because that's very much home for me. I've been here for around about 35 years on and off, but I have worked all around the world. As you may pick up from my accent from time to time, I am English and did work in England. I also have done some work in India, in Australia, and I wonder if anyone can guess what flag that is. It's an African flag. I lived in Tanzania for 2 years, and have also worked in Silicon Valley in the US for a short period. So although a lot of people know me for perhaps my HR background, they may not be aware that I also have an IT background as well. As far as transport and logistics goes, I do have had periods working with a number of different companies. I was working for P&O Nedlloyd before it was merged into Maersk. When it did merge into Maersk, I spent some time working at Maersk as well. I spent some time working for the Ministry of Transport, and for almost 8 years, I was also at the Ports of Auckland as the General Manager, People, Systems and Technology there. So I looked after people, processes and technology. It's unusual for people to look after all of those areas, but that was my lot in life. That's probably all you need to know about me. I'll just talk about what I'm going to cover today. First of all, I'll talk about why thinking about the future outside of our industry is important. A lot of people don't necessarily do that. I'm going to give you an example of an innovation which may change some of transport's infrastructure, something you may or may not have heard of, but something which, when I first started talking about it, was a bit theoretical and is now almost a reality. A very exciting innovation around fuel. Talk about the next generation of robotics and automation for logistics and vehicles. A possible disruptor for freight. And we'll end up talking about how the Internet of Things is already impacting our roads and our cities. But first, we're going to start with a question. And what I need to do is stop sharing and start a poll here. So I'd like everyone to take part in this poll. Have you got the poll in front of you? I'd like you to pick which answer best applies to the organisation that you work with. There's no right or wrong answer. It's just it's a straight pick 1 to 5.
Looks like, Diane, that our audience has decided to answer both polls at once. So they're obviously really, really on the mark today.
That's fine.
It's all good. I'm actually waiting for someone to put in an answer for planning. What's that? To be the disruptor. I notice no one's done that yet.
Okay, we've got about 2/3 of you to do it. So I'll give you about another 20 seconds for the stragglers. You need a bit of time if you're doing both polls. I was going to do the other one a bit later, but that's fine. Okay, we've got the most of them in, not quite everyone, but so I'll stop it there and I'll share some results with you. So fortunately, there wasn't anyone that's picked number 1, planning. Believe it or not, I have done this talk where somebody said that, that they just work from day to day. It seems that most people, the highest figure was between 3 years and 10. And the majority, it was 2 years to 10. But we've got a few people who are looking out further than that for 10 years. Some of that does, of course, depend on the industry that you work in or the type of work that you do. Obviously, companies like tech companies have shorter timeframes because they're much more agile and they tend to work on very quick life cycles. Whereas something like an infrastructure company would typically plan out more than 10 years ahead because some of their infrastructure may take that long to build. Seeing as we have got the second one as well, this was quite heartening to me because it's not uncommon for me to find companies that when they're planning, they just take last year's results and stick a percentage on and say, well, that's the targets we've got for this year. It looks as though there is something, although 24% said we look at what we've done in previous years and then extrapolate out from that. There are quite a few people who do create scenarios and think a bit more broadly. So that's quite heartening for me. I will just go back to sharing my screen again. That's the question you've just answered. What I wanted to say was, what does a futurist do? And if I had $1 for every time someone had said, oh, you're a futurist, so where's your crystal ball? I'd be a very rich lady by now. But it's important to recognize that the role of a futurist is not to predict the future. We can't tell you what the lotto results are for next week. And we probably can't tell you exactly what's going to happen in 2, 3, or 5 years' time either. However, there are some things that we do. The first thing we do is to scan and collate what is new in the world. And jumping ahead. Sorry, knocked something in the way there. Go back, right. So we scan what is going on in the world. And to do that, we need to have a particular competency called curiosity. You need to be curious about all sorts of things, not just the things you know, not just things you like, but be curious about everything that you do.
Diane, just a quick interjection here. I think your sharing isn't working because we're not seeing the presentation on the screen.
Oh, you're not?
Could you just double check again?
I will give it another go. Okay. That's what I was just talking to. So is that better?
Yes, that's great. Thanks.
Right. So essentially, we need to do cross-disciplinary research and to identify innovations in one sector, and then use a mixture of analysis and intuition to think about how that might disrupt a different area or a different industry. And also, we have to do a fair bit of validation of the data that we collect by examining a range of different resources, because as you know, there's a lot of fake news out there. So we need to check and cross-check to find out. It's not enough to just do a Google search on a subject. You do need to dig a little bit deeper than that. And what we don't do is analyze trends in isolation. A lot of people say, oh, a futurist is looking at the trends and then extrapolating what that means for the future. What we say is we're looking for signals, and signals come from a variety of trends. So you may see trends overlaid with other trends, which signal that society is moving in a particular direction. And finally, from all of that information, we create scenarios of different possible futures. Nobody knows what the real future is going to be, but we can make some educated guesses about different types of futures depending on different variables. And what we do is use that to build organizations that are agile enough to flex within those range of scenarios, which is what I've just said. We work on a research framework called STEEP, which means that we don't just look at our own industry, we look at the sociological, technical, economic, environmental and political signals that are out there. It's very much a cross-disciplinary approach, and we're forever scanning and revising. We say that scanning is the lifeblood of any futurist. You can't call yourself a futurist if you don't scan, because information is coming in all of the time and it's changing all of the time. And you'll see some of that later in the presentation. Signals, not trends, I've mentioned. And what we do when it comes to planning is we plan backwards. What that means is we say, if we want to achieve, to look in a certain way in 10 years' time, let's build a scenario around what that looks like. And then we'll decide what would that look, if we're going to be there in 10 years, what would that look like in 8 years? And if we need to be there in 8 years, what would that look like in 5 years? And if we need to be there in 5 years, what does that look like at 3 years? And finally, if we're going to be there in 3 years, what are the things we need to do this year? And that's what we create the business plan from. If you just take what have we done before and extrapolate out the other way, the problem is that you're confined by what you already know. And that's what you're trying to avoid when you take a future approach. How the world responds to STEEP. Well, if you take the environmental part of STEEP, you'll know that there's been great pressure on companies to look at sustainable solutions to their business. They look at it first because there is political pressure for that, because there's social pressure for that. And these days, there's even financial pressure for that, because people will make their choices. So an example that might be relevant to transport is people got together and said, well, how do we make an asphalt that is eco-friendly, given that asphalt is not intrinsically eco-friendly? And they came up with warm mix asphalt, or WMA. So that reduces energy consumption while simultaneously minimizing vapors and greenhouse gases during the production of asphalt in comparison to conventional. Now, I'm not an engineer, so I don't know the ins and outs of this, but I just use this as an example of how innovation in one industry is driven not by pressure from within the industry, but by pressure from society coming from outside of the industry. You've already done that poll, so we won't do that. Why do we look beyond our industry? Well, Rob alluded to this a little bit earlier. Airbnb had no motels, no hotels, no rooms. And it didn't come out of the hospitality industry, it came out of tech. Uber, we all know about. The same thing with Trade Me and Amazon. Amazon doesn't own a single book, but they have completely disrupted books, and booksellers around the world have been going out of business. Of course, they've expanded well beyond books, but you see the point. Autonomous cars did not come out of the car industry, at least not originally. We are seeing the car industry react to the fact that autonomous cars were attempted by people like Google, and then they thought they better get in on the act. But it was a case of being disrupted by the technology companies not coming out of their own strategic plans. And what is very current at the moment is the rise of the neobanks. So a neobank is basically a company that will do banking for you without the bricks and mortar. And often they are owned by the phone companies, particularly in Africa. The mobile phone companies not only manage the banking, but are themselves part of the banking solution. The point of all this is saying, if you don't look outside your industry, you won't see who is about to disrupt you. So the first, now getting on to the interesting stuff, how biology has triggered innovation in roading infrastructure. So I wonder how much you know about nanobots and microbots. So nanobots emerge from the biological sciences where molecules have on and off switches. They program on and off depending on what they need to do. And in medicine, they're used to seek out pathogens. So the nanobots that were created showing great promise for treatment for some cancers. And you'll see from the picture there an example of that and how small they are. The nanobots, a nanobot is 1/1000th of a meter, or 0.00001 millimeters. So they are tiny. So what has that got to do with roading? Oh. Well, there's a project going on currently at the Sheffield University, led by Professor Kirrell, to use micro robots to inspect and repair roads. So the micro robots have two roles: inspection bots, which go out to navigate, explore, and report on the roading conditions. So they have the ability, they're equipped with sensors. They're called micro robots rather than nano robots because they are a centimetre long, so they're not quite on that same nanobot scale, but they come out of the same basic stable. These bots will go out and can actually be implanted within asphalt or under the roads to do this inspection. And the second kind of microbot, in this case 2.6 centimetres long, can carry cement and adhesives to make repairs remotely. So they might be remotely controlled, perhaps autonomous in the future. So why would you actually want this to happen? Professor Kirrell's had $7.2 million of funding from the government to develop and test these microbots. Why? Well, the UK has 1.2 million road excavations each year that cost circa $63 billion a year. So $7.2 million of investment doesn't sound like sounds like a really good deal. So where are they now? How far off is this? Well, the field trials, if successful, will be starting next year. So the first microbots will be out on British roads, mending those roads, or identifying potholes before they become potholes. So where cracks are appearing, where things need to, in the past you would have had to dig up the whole road, doing preventative maintenance. So changing tack a little bit, innovations in geology and physics and how they might revolutionize fuel. Here I want to talk about microdiamonds or nanodiamonds. Nanodiamonds are tiny, tiny, tiny diamonds which are found in metamorphic rocks, and they appear where continental collisions happen. In other words, they need to be formed under extreme pressure and usually more than 120 kilometers below the surface. So the nanoparticle diamonds are around about 1 micrometer long, so 0.01 of a millimeter in size. Interestingly, these compression diamonds also are formed as the byproduct within nuclear reactors and are very radioactive. What does that mean for roading, or for energy, fuel rather? Well, generating a virtually inexhaustible source of energy from radioactive material has long been discussed and is already being employed in a variety of non-diamond technologies. Microdiamond batteries are a theoretical application of this technology, but current developments suggest the reality is actually closer than you might think. There's a company called NDB in the US at the moment who have created one of these batteries and are now intending for it to go out by 2024, by 2040. They are suggesting that it would have solved our fossil fuel problem. So what I'm going to do here is to switch and just show you a short clip. Oops. About the nano diamond battery.
Produces waste that must be stored to protect the people and the environment from harm. Because of the nature of nuclear products, this storage must be undertaken for thousands of years until the waste becomes safe. At our company, NDB, we asked ourselves, what if we could recycle that nuclear waste into something good? Globally, there are 34 million cubic meters of nuclear waste. The cost to manage and dispose of those byproducts is over $100 billion US. Utilization of radioactive waste has not been thoroughly investigated. At NDB, we propose to reuse nuclear fuel by recycling it to extract radioisotopes. This enables the nuclear option to remain sustainable for the long term and promotes a clean energy source in a safe and secure environment. Isotopes from the recycled nuclear waste release a high level of energy particles. At NDB, we said to ourselves, what if we could harness that energy? Semiconductors such as synthetic diamond or similar materials could be the answer to this question. The energetic electrons released from radioactive decay would scatter and deposit energy into the host semiconductor. This would generate a shower of electrons that generates power from the NDB. The isotope, together with the host, generates electricity on its own. We can make a battery that bleeds electricity from recycled nuclear waste. This saves a tremendous amount of taxpayers' money by eliminating the need to store nuclear waste. Best of all, because of its long half-life, this new battery doesn't run out or need to be replaced during the lifetime of the device. The battery is coated with a non-radioactive material that prevents radiation leaks due to it being one of the hardest materials on Earth. This battery is extremely safe and tamper-proof with no moving parts. It is a clean and green energy solution, and when fully expended, it turns into harmless byproducts. This battery provides a solution which will effectively self-dispose nuclear waste. Here's how the battery works.
I'm going to stop it
DNV,
there because
the base structure of the NDB.
It is quite a long quite a long clip. But if anyone would like to do it, I can. Sorry. If anyone would like to follow up on that, I can certainly send the link out. The point of this is that there is a car battery that is currently in development. Now, you will know that one of the biggest criticisms of car batteries is that they don't last very long. They're difficult to dispose of. And although they're clean and green in the short term, they still have their disposal problems. With the battery, NDB battery, the estimated life of the battery for a car or a truck or any heavy material would be somewhere in the region of 28,000 years. That's 28,000 years. In other words, these batteries will last long beyond our lifetime and could conceivably solve some of our fossil problems. The vision statement of the company NDB is to reinvent electricity and create a planet without fossil fuels by 2040. What is holding things up just at the moment is convincing the world that the radioactivity is safe. Well, so it may be caught up in regulation for a little while longer, but it is looking very hopeful. Moving on, the next generation of automation for transport is around autonomous vehicles and robotics. So if we start with vehicles, there are a range of levels for autonomous vehicles. Human controls, 0 is when the human does all the controlling. Level 1 is where computer functions replace some things that humans do, which has been around for a long time with things like cruise control and more recently lane alarms to keep you in line. Level 2, the car drives itself, but the human still needs to stay alert to take over during new and emergency situations, because there will still be things that the car will not be able to cope with. Level 3, the car does its own driving and the driver can basically take their eyes off the road, take a nap if they really want to, but there may be times when they still need to take over. At level 4, the driver doesn't need to do anything. The car drives itself, but a human can still choose to drive it if they want to. And level 5, the vehicle operates entirely without a human, and the car may not even have controls like a steering wheel or pedals, so they can't even be driven by a human if they wanted to drive it, though they might have a remote control option. So I'm sure that many of you are already well aware of the range of autonomous vehicles out there. They've been used since 2006, actually, in the mining industry. These trucks have been ploughing the mines in Australia and also in Arizona in the States. They originally were very limited in their scope, in that they had to work away from humans because they weren't necessarily that reliable. But by around about 2018, they've got them off pat, and now they're pretty standard all over the world in mines. I don't know if all of you know that Waymo launched a taxi service in the screen has frozen. So Waymo launched, oh, there we go. Launched a taxi service back in October the 8th, 2020 in Phoenix, Arizona. So within a 50 square mile radius of Phoenix. These are fully autonomous taxis. They do not have a driver. So the future is already here. Up at the top there, you've got the Yarra Birkeland, which is the first autonomous ship that was launched in 2020 in Norway and is currently plying the fjords. And Waymo also have a series of trucks. They are now driving between Houston and Fort Worth on real roads. So these are not done off-road. These are part of the standard service. And because I work for Ports of Auckland, I have to also show that ports are using autonomous vehicles for as straddle carriers these days, either straddle carriers like this or ASCs in some ports. And these are actually level 5 in that there is no one to drive these. These are driven entirely by the computer system, and but they don't necessarily have the machine learning that is the holy grail, I think, of autonomous vehicles. Alstom are known for their trains, and they have launched a number of different train options, particularly freight trains. So the picture there on the top left is one of their freight trains that is already in operation. And below that, you've got a shunter that is shunting. And these work through digital twinning as well. So they have virtual copies of everything on board, and they can be controlled remotely. Why fully autonomous is not really common? Well, social acceptance is one of them. Very few people seem to believe that autonomous computer-controlled cars can drive safer than they can, but then I've never met anyone who didn't think they were a good driver, whilst the reality, of course, is quite the opposite. The second reason is ethical programming. So one of the challenges of autonomous vehicles is that it's very difficult to program ethics into a computer without locking it in so that it can't change. In other words, if you take as an example, if an autonomous vehicle had the choice of going straight ahead and running down a human, but if they swerve to the left and go up on the pavement, they may also hit someone on the pavement and injure them as well. What choice should they make? Now, humans make decisions like that all of the time, not necessarily good decisions, but sometimes the right decision, sometimes the wrong decision. But programming every variable into autonomous vehicles is still a challenge. Sensors are not yet as well evolved as we would like, particularly if the light is low or if the weather is bad. There are some limitations of machine learning. Some of that links into that ethical programming. And there's also quite a lot of political inertia around regulation for autonomous vehicles. But I am a believer that probably within the next 5 years in New Zealand, autonomous vehicles will be on our standard roads. I love to be, I may be proved wrong, but that's how what I would predict, even though, of course, futurists don't predict. It isn't just vehicles, of course. Here's an example of a port that is run entirely without humans. There's just one person managing the whole port here. The reach stackers there are automated, as are the cranes. And of course, robotics and warehouses, for those of you who are working in logistics. Drones doing inventories are now pretty common. Autonomous forklifts and movers are pretty much changing the way that warehouses are done. Even the supermarkets are beginning to bring in inventory drones as well. I haven't seen one, but I'm told that that is something that is on its way. And of course, you have the autonomous delivery. We've got the drones. Pizza Hut is probably the one that most people have heard about, but there are a lot of companies that are looking to direct deliver and bypass trucks and bypass the traditional routes and use drones. There are some challenges there about airlanes, and as a glider pilot, I'm fully aware that it's not as simple as throwing everything up into the air to solve the problem. You just solve a different problem, you cause a different problem. And how far can autonomous vehicles go? Well, I've got another quick clip that I will show you.
This is no ordinary plane. Its advanced autopilot system can take off, fly, and land an aircraft, all without a pilot. The system is being developed by San Francisco-based startup Xwing.
What makes Xwing technology different from the current state-of-the-art is the level of autonomy. current aircraft have a lot of automation, which is flying to different waypoints, flying a trajectory, but they're not able to take off and land on their own. They're not able to taxi on their own. They're not able to automatically detect other aircraft and avoid them on their own. So it's being able to have this decision-making capability that stands us out from the competition and the existing state-of-the-art.
Parts of the technology are still being tested and modified, but founder and CEO Marc Piette says it's a matter of months before the software hits the market.
We're at the dawn of a new era in aviation that's driven by autonomy, autonomous flight technology. It's something that's going to be that we think is going to be as disruptive as the dawn of the jet age and what that did for long distance travel.
Piette says X-Wing is targeting regional cargo delivery, aiming to license their technology to flight operators carrying cargo to smaller airports. In August, the company received a Part 135 air carrier certificate from the Federal Aviation Administration. That means it will be conducting interstate, foreign, and overseas transportation, or will carry mail. With its successful testing, X-Wing joins other aviation companies striving to develop the autonomous technology.
I'll stop it there, but you get the idea.
European jet maker Airbus said in June it had completed a 2-year test program.
There's definitely a push to get air freight autonomous, and X-Wing again don't come out of the airline industry, they come or the freight industry, they come out of the gaming industry. Moving along, I've got something that I'd like you to have a think about. Additive manufacturing, better known as 3D printing. It's the construction of three-dimensional object from a 3D model through processes controlled by computers. It involves depositing, joining, solidifying materials to create three-dimensional objects. Materials such as plastics, liquids, powder, etc., etc., etc. I would like you to have a think and maybe put into the chat, why might that change the entire business model for transport and logistics? I'm going to give you a couple of minutes just to have a think about that question. So why does 3D printing have the capacity to completely disrupt the logistics industry? Pop your ideas into the chat. Some good answers coming in. Okay, I'll stop there. Some very good answers coming in. I think many of you got the idea that it's definitely going to cut down on how much needs to be transported. Why would you bother importing parts for something when you can just get the template, a digital template for what you want and put it in a 3D model? It was interesting that I first came across 3D printing back in 2010. I was at a World Future Conference and the speaker at the time had a prototype 3D printing model. And he said, do you realize that within 10 years, we may get to the stage where we could actually buy a 3D printer in a shop? What actually happened was 3 years later, those 3D printers were in shops. And by the 10 years that he was talking about, people were making just about everything. I was in Rotterdam in 2017, and I watched them 3D printing a rudder for a container ship. They said that typically that rudder would have taken somewhere between 8 and 10 weeks to make. With the 3D printer, which was printing in metal, the rudder was complete in 4 days. The argument would go that 3D printing is getting cheaper and cheaper and cheaper, and it's getting more and more sophisticated so that it can use multi-materials. And there may come a point where everyone has one in their back garden and just prints off whatever it wants. When we get to that stage, there will be a huge reduction in what needs to be shipped around the world. Or there may just be a 3D printing down in your local store. I don't know how far it will go. But conceivably, the dominance of the container may be nearing its peak. So at the moment, containerization pretty much rules the cargo, both on land and sea. But maybe the time of shipping goods around the world is limited. I don't know what the time frames will be. Somebody put into the chat, and I totally agree, that it doesn't mean that we don't ship anything around the world. There will still be the need for the bulk materials. It may just change the profile of what is shipped more to bulk than to finished goods. But it certainly means that we might need to reconsider whether we need to invest in large ports, or if we do invest in large ports, how much of that is dedicated to containerism. I was at a shipping conference back in 2017, and I had the awful job of saying what I've just said now to somebody who just before me announced that they were opening a huge new container terminal for 5 million TEU, just as I was saying that maybe we won't need containers for much longer. So that was quite an interesting discussion. The last thing I wanted to touch on, I could talk about this for literally for weeks, but I've just highlighted a few things, is the Internet of Things and how it's already impacting our transport and our cities. If you are not familiar with the term Internet of Things, it's describing all that group of things such as sensors. The key point is it's around sensors, around processing, and around data. So it includes things like digital twinning, artificial intelligence, blockchain, and all those sorts of virtual technologies that are becoming so much part of our lives. And I've picked some examples of things that are already happening. So one of them is INRIX, who work out of Kirkland in Washington in the US, who have developed real-time traffic management systems where they manage traffic behaviours in real time by using a network of technologies, sensors, smart cameras, GPS, Bluetooth, Wi-Fi, blah, blah. And they use this to reduce congestion, bottlenecks, parking, and other traffic issues, and also has the potential to improve public transport reliability. Another example is Consiris in London in the UK. They use sensors for real-time data on driver behaviour and road conditions. So they use sensors to analyse driver behaviour, such as speed, tailgating, braking, different reaction times between day and night driving, and so on. So beware, if that's introduced, Big Brother is watching you. They can also analyze driving and how it relates to different weather and road conditions and provide data on collisions and near misses. Another company, Dash, based in New York, and they do real-time monitoring and prediction. So they do monitor fuel consumption, predictive maintenance, pinpoint repairs, analyzes the impact of driving habits, and so on. And they can even say such and such a piece is broken. I know the best shop to buy that from and the mechanic that I want to mend it, and drive the car there. There's Maersk, the biggest shipping line in the world. They use internal sensors to gather and broadcast data on everything from temperature to humidity to CO2 levels within containers. And they also track where the containers are. It used to be that containers were always getting lost, not so much anymore. Where it gets exciting is that when there are problems, they can automatically send messages down to the customers who are owning the containers and advise them if anything is going wrong. And it's also improved security. And of course, the smart cities and things which are currently going on. We've got cities where they can adapt lighting in an area according to the level of traffic. So when there's no cars driving down the road, the lights will dim. They can monitor the number of people needing transport and send appropriate size vehicle to the exact location of the passengers. They can even monitor the litter bins and street litter and trigger the cleanup when it's required. So these are things that are already happening. These are not the future. And so on and so on, so on. We don't have time to do them all, but I could probably give you another 30 examples. William Gibson famously said, the future is actually already here. It's just not evenly distributed. So when we're talking about the future, I can't tell you what the future is, but what I can tell you is some of the innovations that are happening that may be building the kind of future that we want. That's William Gibson. I also think it's important to remember that one person's disruption is another's innovation. I think Rob mentioned that at the beginning. The best way to predict the future is actually to invent it. And that's really why futurists do what they do, which is if you can decide the sort of future that you want to have, you can start to predict, you can actually start to invent the future that you want. And you will see that there's an interesting play between science fiction and science fact, that people will dream something up and somebody will go out and actually invent it. So I was hoping that we could break into groups, but we're not going to be able to. But I do have some questions for you to consider in the context of your own company. Perhaps you can think about them and take them away. How well informed are we about the technologies that are changing the future for us? So depending on the type of business you're in, do you know what technologies may come in from somewhere outside? And if we know that, what might we do differently about the way we currently plan? And finally, what's the most important thing that I learned today? The one thing that you have to watch out for is something that futurists call educated incapacity. And educated incapacity is the state where you know so much about your own industry that you're incapable of seeing what is coming in from outside. So those threats are not so obvious. And if you can't see what's coming, you're not likely to do anything about those threats. And my closing thoughts are from Alvin Toffler, who said the illiterate of the 21st century will not be those who can't read or write, but those who cannot learn, unlearn, and relearn. And when you know a lot about your industry, it can sometimes be quite challenging to say everything that I've learned over the last 20, 30 years of my career may not actually be relevant anymore. And I've certainly found that in my career, that I look back on the things that I learned when I was 25, and I look back now and think there's nothing there that's going to help me with the new world that we're living in. And the real skill is to unlearn what is no longer relevant and relearn what's going to be relevant for the future. And that's what I had to say. So,
Diane, thank you very much. There's some questions that have arrived in the chat already, and I'll just read them out for you. One's from David Creel. Which port was used in the example of being fully automated that you showed on one of the previous slides? What was that port?
I can't remember exactly. It was an Asian port. It might have been Busan.
Okay, well, it's something I think.
But I won't swear to that. But there are actually fully automated ports are becoming more and more common. If not fully automated, they're close to being fully automated. So, for example, London Gateway in the UK on the Thames is a fully automated terminal and works off a staff with only 5 people who are basically monitoring stuff. I've been there and I've seen it, and it's quite fascinating. Guangzhou, I think, in China is fully automated, and I think Los Angeles is close to being fully automated in 1 or 2 of their terminals, but not all of their terminals. But I think around the world, there are multiple terminals that are automated now.
Yes, in fact, Yingxie has just pointed out that the picture is actually Yangshan port in Shanghai.
Oh, yeah. Okay. Yeah, I knew it was in Asia somewhere, but.
Another question here, Diane. Can 3D machines print things like iPhones and computers at the moment?
I cannot answer that. I think perhaps not, but they won't be far away. I think that they can probably print all the components for an iPhone and a PC, but they won't necessarily automatically put them together.
Well, before I ask for further questions from the floor, and then what I'll do, participants, is I'll unmute you on the mic just instead of getting you to type in the chat, because I think the speed of the connections you've all got should be all right. Some of the points that I picked up tonight was what, as you said earlier, Diane, if you don't look outside your own industry, you won't know who is going to disrupt your business. And I must admit, with my transport background, I found the microbots for the road surface repairs in the UK, the £7.2 million funding to develop a solution to address a £6.3 billion per annum operational expenditure issue. That's really showing how compelling, ROI can be when you actually target it in the right way. And I was fascinated with the NDB battery that takes its energy from nuclear waste, a battery that lasts 28,000 years. That's amazing. And the fact that, as you say, the developers of the X-Wing regional autonomous flight software come from the game software development sector. And you also mentioned about 3D printers in the back garden. And I do like Murray King's comment about 3D printing food, because maybe we are closer to the age of the Star Trek food replicator than we think. And of course, lastly, achieving IoT, using IoT to achieve real-time traffic management. There's a project that I'm about to work on in Tirana, Albania, where the money is actually coming from the German overseas aid agency, GIZ, and they're focusing on just that, using IoT to achieve real-time traffic management to help speed up the flow of freight movement across the city, and also public transport service movements. So no, thank you very much, Diane. Do we have any more questions? Sorry, I should say correctly, do we have any questions from the floor? Please either raise your hand or let me know and I'll unmute your mic, or type it in the chat.
Murray, I think, has his hand up.
Oh, good. Okay, let me just get to Murray. and unmute him. Allowed to talk. Where you go, Murray.
Right, you overlooked it. It was in the chat, but Diane, you're associated with Zuri,
Mm-hmm.
and I wonder whether people who make products based on IP have an inbuilt IP or product design or things like that have an inbuilt defense against 3D printing. Unless people are very, very skilled and willing to breach copyright, you shouldn't have a problem. What do you think from the Zuri perspective?
Look, I don't know what all the IP issues would be. I'm not an IP expert. I don't know that we are quite at the stage where people are printing, as I say, printing iPhones or whatever they may. What I do know is that they are currently printing doing skin grafts, printing cells to replace kidney cells, and in fact, there's probably more use in the medical industry for 3D printing at the moment than even in manufacturing. It's becoming very, very common there. The answer to the food question is yes, they are looking at finding ways to print food, but I think a lot of that depends on what are the raw materials you need to do, and it's actually changing things at a molecular level that's the challenge there.
We're a little way off Star Trek.
Yeah, I don't think we're quite at Star Trek level there, whether it be soup, tomato, as Tom Paris said in Voyager, I think. But I think it will become an interesting question, and probably one that will spawn its own legal department when we get to the stage that 3D printers are able to do things like copy things completely. But even now, they work by scanning objects and doing internal scans as well as external scans, so they can see what's going on inside. And I think we had an example at Northern Branch not very long ago where we had some demonstration of 3D printing, which was very interesting.
Another question has just come in, Diane. Would mass application of robotics and automation per se resolve the supply chain logistics disruption caused by the COVID-19 pandemic?
I guess it I think some of the disruption to the supply chain is, how do I put this? It would, in the sense that some of the disruptions to the supply chain are holdups because of the human impact on the logistics chain. So short staffing in ports, which have held ships up predominantly in Europe and Asia, and also industrial disputes in the US. With robots, of course, they don't worry about that sort of thing. So whether you had, you could deliver stuff to ports, put it in an automated port on an automated ship, and then do the same at the other end. They won't get COVID. So I guess, yes, it would solve the problem. I'm not sure that we've joined up all the dots to get there quite yet, but certainly the potential to do it is there.
Any other questions from the floor? Well, if there are no further questions.
Oh, there's a hand up somewhere.
Oh, good, good. Lovely. We like that.
I'm not sure who it is. Pete Homburg.
Oh, yes. Pete, hang on, Pete. Just allow. Away you go, Pete.
Yeah, g'day. Hey, so thanks for that. It was like really interesting. And one of the things that kept going through my mind during this presentation was how, many years ago, wars drove a lot of military technology, and a lot of the military technology ended up influencing technology advancement in everyday life. And but that's certainly not the case nowadays. And you know, it's certainly commercial industry that's pushing the boundaries, because that's what they need to do to stay competitive in the market. And from my experience, you're seeing certain areas in defence, particularly in sort of information domain and information warfare and cyber and so on, advancing quite quickly, but other areas really lagging behind industry. And I'm just, I guess, from a from that perspective, I'm wondering if you've seen or have any examples of where perhaps some of these technologies are being implemented in defence or military applications.
Not directly is the short answer. The long answer is that automation is quite widespread in the military. As you may be aware, that drone technology has been used in Afghanistan recently. There are automated robots that go out and defuse bombs. So robotics is certainly one area where that's happening. I have no doubt that the military are using 3D for manufacture of parts and stuff like that. I haven't personally witnessed that, but I have no doubt that it's happening.
Right, got some more questions coming. First one's from Cameron Taylor. For warehousing, DC and FC automation, current solutions are very expensive and like pouring liquid concrete, as he describes. Do you foresee, Diane, IoT and robotics automation being miniaturized? For example, many robot pickers versus traditional conveyors and sorters. What might that look like?
Yeah, it's certainly possible that things will become miniaturized, and also it's quite likely that costs will come down as it becomes more and more common. It's like with anything, when you're first developing software of any kind, there's a lot of R&D cost that goes into the development and testing of software. But as things become mainstream, costs come down. I think that technology in warehousing did start off mainly in the area of forklifts and carrying parcels around from place to place. Now drone technology is taking over quite from that. There's also a lot of quite human-like robots starting to appear on the market to do heavy lifting. I don't think that the level of robotics is going to reduce anytime soon. I think it's only going to go up. There are so many advantages which range from health and safety through to efficiencies in that a robot can work 24 hours and don't ask for holidays. Having said that, I am an optimist when it comes to jobs, because I think a lot of people think that robotics means that we no longer have jobs. I think that people will be redeployed into other industries. There will be new things for people to look at. But to go back to the question, will things miniaturize? I think yes, they will. But that doesn't mean that some of the larger solutions won't still be applied. I think it depends on the type of company. And I think the choice that you will have will increase substantially. And with choice comes competition, which will bring prices down.
Phil King's got a question here, Diane. He's asking, what role do you feel that climate change and decarbonisation are having in driving change and disruption?
I think that now that climate change is very front of mind for a lot of people, there's been a lot of things. I was just watching a program about an Inuit family 2 days ago, actually, on the melting ice, talking about if anyone wants to deny climate change, come and see what's outside our back door. I think it is. I think that I think I mentioned during my presentation 10 years ago, it was very rare for a company to prioritize sustainability, of which a lot of that is around environmental, but not all, but quite a bit of it is. Now it's pretty much a must-have for any organization that wants customers, because customers expect that. I think that far more innovation is required to tackle climate change, far more willingness. And I don't think that I think there's a lot of people trying, and I think the problem that we have with climate change is probably the political will, in that politicians are too scared to make decisions about retiring old industries. But personally, I feel that the social pressure to do so will become so great over the next 5 to 10 years, particularly with the new generation coming through. Certainly, most people that I know under 30 and most people that I've had a chance to talk to are far more aware of the critical nature of climate change than certainly I was when I was their age. And I think that new generation will certainly drive that change, but that's not an excuse for us to not start now.
Last couple of questions here, kind of an observation and a question. The first one from David Creel. Perhaps we didn't model the change in human consumption as a result of the global pandemic. So is this a case of unlearning what we already know?
Absolutely. I think I lost count of the number of people who keep saying, I can't wait to get back to normal. And in fact, I don't think we will ever, if normal means what we had before the pandemic, it's never going to happen. I think that we've moved on as a world, not just New Zealand, but as a world. And I think that people didn't model changes in consumption. They didn't understand what would happen with so many people working from home. They didn't understand what would happen if supply chains were disrupted. And I think most companies are still pretty unaware of how, if and when we hit our 90% and go back to at least being able to live our lives a little bit freer, it's still not going to be the world that we left. It's going to be a very different world. And I think that maybe it will become a lesson for many people. Maybe they will use it. Maybe people who found it difficult to change in the past will see the importance. That's what I hope anyway, that people will recognize that it has been such a paradigm shifting experience for just about the whole world, that it will prompt them into recognizing that change is inevitable.
Another question has just arrived here, Diane. Are the current robotics and automations that you described, or that we're seeing in general, are a lot of them now starting to be made from recycled materials?
Yes, they are. I've seen examples where plastics have been recycled into making materials. I think that people are more aware of the need to work in a more eco-friendly way. Having said that, I don't think it applies to everything. I think that some of the early robotics didn't really consider that. I think some of the later things coming through are a bit more, are a little bit more conscious of that. As to the percentage of how much would be using recycled and not, I don't know the answer to that.
Just last question that's come in. It's more of an observation from Chris Gunn, but I'd like to turn it into a question for you, Diane. Obviously, with 3D printing allows you to be able to produce locally, in your back garden or close to you, things that normally you'd have to wait ages for. And you use the example of the rudder being 3D printed within 4 days as opposed to 4 to 6 weeks over in the Netherlands. Is it possible that in the near future, we might see in New Zealand the manufacture of freight and passenger rolling stock instead of being overseas sourced? Is that ever going to happen? Is there the potential for that to take place?
Oh, there's one simple answer to that, and that's yes. I think that it's inevitable. Places like the shipyards in Rotterdam are enormous. They have a lot of funds, and it enables them to set up the infrastructure needed for something like printing a rudder for a ship in a way that a New Zealand company would not be able to afford. However, once they've broken the ground and they've done the prototypes, they've tested it, they've done all the heavy lifting around the development, it becomes much easier for people to then come in behind them and produce things more cheaply. And I think it's inevitable that New Zealand will become a lot more self-dependent in the future around some of its manufacturing, rather than having to import as much as it does at the moment.
Great, thanks, Diane. It really brings into context the phrase, thinking global and acting local. So on behalf of everyone here tonight, Diane, I'd like to thank you very much for your time. It's been a really, really interesting webinar. And I'd just like to let everyone know here that this webinar is being recorded tonight, and it will appear as a YouTube video up on the CILT YouTube channel within the next 3 to 4 days. And the slides that Diane showed tonight will be available uploaded to the CILT website for you all to download afterwards at your leisure. And so thank you very much. And Alice has just popped up here. Very insightful presentation, Diane. Thank you very much for your time tonight. And to everyone here, our viewers, I should say, tonight, stay tuned. We have more webinars coming up. Very interesting one coming up in November, which we're just preparing at the moment, and hopefully another one in December. So we may be in lockdown, but we're trying not to actually slow the pace of things here in CILT Northern. So thank you very much to everyone for joining us tonight, and we hope to see you all again. And thank you very much once again, Diane, for your time. Really, really good.
Welcome.